Hello, my name is Angad Kahlon, and I'm in Comp 380, which is Introduction to Artificial Intelligence at U of V for the semester fall 2023. This is my video for Lab 4, which is about Stochastic Local Search, which I'm just going to be calling SLS. So part one, which is the preliminary questions, we have question A, which is in local search, how do we determine neighbors? So in local search, neighbors are just variables that have had some sort of a change. It could be a value change or any change made when assigning the variable. So for example, if we have a variable A, which had a value 1, we could have a neighbor of it, which is variable B, which has a value 2. Question B is what is the difference between random walk and random restart? A random walk is taking some random steps, and a random step is just a movement to a random neighbor. A random restart, however, is when all the variables are assigned new random values. Question C. What are the two key weaknesses of SLS? One key weakness of SLS is that there's no guarantee a solution will be found even if it exists. Another key weakness of SLS is that it's not able to prove if there's no solution. And the source for all these questions is Module 4 Constraint Satisfaction Problems Part 2 slides. So in this lab, we're given the scenario about traffic flow where we are on the city planning committee and we have to describe the flow of traffic in a particular residential neighborhood. We can decide if it's a four-way stop, a roundabout, or an uncontrolled section. So we have two considerations, however. We have a school and we have a truck route, and the stars represent all the intersections. The considerations are that by the school, we need a four-way stop for the safety of the students and staff there. And we can't have consideration number two is that we can't have roundabouts along the truck route as it is not safe for large trucks. So to understand how to do this problem, we're going to take a look at a smaller problem where we have only three intersections. So we have intersection 1, intersection 2, and intersection 3, and we have three constraints, C1, C2, and C3. So C1 is that intersection 1 must be a stop sign. C2 and C3 are constraints that consecutive intersections, which means intersections right beside each other, cannot both be stop signs and cannot both be uncontrolled. So this figure has been also randomly initialized the values for each variable. So we can see intersection 1 is uncontrolled, intersection 2 is uncontrolled, and intersection 3 is a roundabout. So given all the information above, which variable will we first select and what value will we assign to it? So we have to select the variable with the most conflicts and assign a value that minimizes the conflicts. So the variable with the most conflicts is intersection 1, and the value we need to assign to is stop. So it's the one with the most conflicts as a constraint as the constraint on it is that it must be a stop sign, which it is not currently. And assigning a new variable to inter one, the variable will also solve the inter two. It will also solve the constraints of intersection 2 and intersection 3. If we make this stop, that's going to solve constraint 1, and it's also going to solve constraint 2 and 3, as all the consecutive intersections will not be the same. And we also have that intersection 1 is a stop sign, four-way stop. So random walk is part 4. Question E is saying, with the same partial CSP shown in the figure above, what would we likely to will we likely be able to find a solution within 100 steps using only random walks? So it is I believe that it's unlikely that we will find a solution within 100 steps using only random walks, as random walks are just movements to another neighbor. With the amount of neighbors and constraints we have, random walks would not be efficient to use as it will take a long time to search all the possible neighbors and go through all the constraints. It is also not guaranteed that we will find a solution, therefore we should use additional algorithms to find a solution. So the last part of this lab is using this lab in AI space. So we can see that we have C1, C2, and C3, and we can see our domain is that we have uncontrolled stop or roundabout. If we quickly look at the properties, we can see that this constraint has to be that it has to be a stop sign. Look at constraint 3, which is the same as constraint 2. We can't have both of them be uncontrolled, and we can't have both of them be stop signs. So I'm just going to uncheck that. and we can press OK, and I'll quickly check C2. We can't have both of them be uncontrolled, and we can't have both of them be stop. So if we click OK, we go to the solve section and we run the batch run. So this was with the algorithm greedy descent shows this. So if we do only random walks and we do a batch run, so we can see that the random walk takes a lot of steps and the success rate comes really a lot after. So if we do batch run with um, greedy walk, greedy descent with random walk, we hit OK, and we do a batch run, we can see that it is it's better to use multiple algorithms to find well, the success is only 90, so we'll have to see the pink one, which was just greedy descent, is the best scenario out of all of them. Then, so have we used greedy descent, random walks, and greedy descent with random walks? So that's my lab 4. Thank you for watching.